Welcome to the Energy Desk, a weekly series from Mobius Risk Group analyzing the macro and fundamental trends shaping global energy markets. To take a closer look at any topics discussed on today's episode, head over to our research archive at research.mobiusriskgroup.com. Let's dive in. Welcome back to the Energy Desk, and today, very fortunate to be joined by Peter Corke, the top Australian robotics expert, pioneer in global robotics, lots of experience through kind of the entire 80s, 90s, and into the modern era of really kind of taking the field forward. So very excited to talk to you today about kind of the state of the art and all the interesting things that we might see coming forward and how those affect other industries like the energy industry. So how are you doing today, Peter?
Doing really well, thanks, Alex. I'm happy to be here. Looking forward to an interesting chat.
Yeah. Very cool how we got connected across the world. We had a report out about some of the energy consumption for some humanoid robots, and you sent some feedback, and it was perfect feedback and helped us improve everything in our models and how we're kind of thinking about the industry. So very cool that we got to keep in touch. So, I think today maybe we can start it off just with kind of a brief background about how you started out in robotics and where that kind of took you through the mid 80s and the 90s with some of your pioneering work, as I mentioned, with the vision robotics and visual servoing.
Sure. So I trained as an electrical engineer in a particular discipline called control theory. And I worked in the university lab for a little while. And then my first job after that was with a national lab. So one day there was an ad in the newspaper. They were looking for someone to do robotics. I thought, well, how cool's that? And the lab was just seriously a 10 minutes walk away from the university where I was working at that point. So I applied and I got the job. And the lab this is Australia's national research agency. It's called CSIRO. It's a bit like NIST in the United States, a bit like NRC in Canada. And the lab had just been set up, and it had what was then 1980s era state-of-the-art gear. So it had a vision system that was like as big as 2 filing cabinets, and it had some pretty neat robots. And on my first day of work, the guy who was supposed to be my boss, he said, "I've got another job. I'm leaving." And so, I was in this environment with all this state-of-the-art gear, and my immediate boss had gone. So it was just a fantastic opportunity to play, really.
Yeah, really get into it.
And in the 80s, I think it's true to say that robotics was actually a dirty word at that point. I think there'd been a lot of hype of robotic technology probably through late 70s, early 80s. Robotics as an industry, as a technology, really came into being in the 1960s. And, had some good initial growth. And now I think hypesters got to it. And this is a problem we have to this day,
right,
is with hypesters. So I'm a big fan of the Gartner hype curve. It applies to so many things. I don't know how many times I've been up over the peak and into the valley of despair and all of that. It's tough. So robotics was considered to be a dirty word, and a lot of people in the industry, they just turn you away if you use the R word. And so we sort of would talk about automation then rather than robotics.
Right.
And it took quite a while really for robotics to sort of rehabilitate itself and the name robotics. It probably sort of took my first 10 years of work in robotics. So 1980s, sort of robots that you've probably seen in videos doing work in factories. They're doing welding. They're picking stuff up, moving it from one place to another. That was what robots did. And they did it well, right? They're relentless. They work 24/7. They're strong. They don't make mistakes. The quality goes up. And I think it's probably true to say that to maintain manufacturing in high-wage countries like Europe, like the United States, like Australia, it probably couldn't have happened at that time unless there was robot technology, because it boosts the productivity of the human workers. If they didn't have that technology, then it's likely that all those industries would have exited to low-wage countries.
Right.
I mean, that subsequently happened, but it didn't happen during the 80s, 90s, and early 2000s.
Yeah,
so
lots
much.
of macro factors that kind of led to the exodus in a way. But I think it's especially interesting as, I think the discussions heat up nowadays to bring manufacturing, back to domestic locations or nearshoring, and how robotics can fit into that. But I think before we get too far down that path, I am curious to hear more about some of the earlier robotics applications and also the energy systems that were used to power them in those field applications. So in a manufacturing facility, how were those systems typically used, and how were they powered? And if you have any idea of the energy intensity of those, I'd be curious to get a snapshot of the background.
All right, so the earliest industrial robot arms, and that was really the first robot technology, these manipulator arms. So they're fixed to the ground and they have one tool. And it could be a gripper that picks things up, it can be a welding torch or a glue laying gun, or maybe just picks up, big chunks of car and moves it from here to there. Right. The early ones were hydraulic, because hydraulics gives you a very large amount of force, power, with relatively small motors or hydraulic actuators. Then hydraulics is a sort of double-edged technology. Yes, it's very strong, but you need compressors and chillers and oil tanks and hoses, and it can spring leaks and hydraulic oil goes everywhere. Mm-hmm. So if you really don't have to use hydraulics, you shouldn't. And it wasn't long before electric-driven robots came along, and that's probably when industrial robots really went ballistic. Right. Is when they became electric drive, and that's probably early 80s.
Yeah.
And I think today, I don't think even the biggest robot manipulator arms, ones that can pick up a whole car or can pick up a human in a cab and wave them around, and I've been on the end of a robot arm like that, they're all electric drive. I don't know what the power requirements are for those. It is significant. I think most of them will be plugged into three-phase outlets. Mm-hmm. And I was actually listening to a presentation by a startup here at the conference this week, and a guy was talking about how to reduce the energy consumption of these robot arms by up to 25% just by making the motion of the arm much more smooth.
Interesting.
So unlike electric vehicles, they don't have regenerative braking. Right. So if you've got a motion that accelerates massively in one direction and then stops and then accelerates another direction and stops, that's very wasteful because that energy is being dissipated as heat.
Right.
So at the moment, I don't see many people in the industry being focused on the energy consumption, but I think as energy costs go up, and that certainly is an issue in Europe. Energy costs are going up.
Right.
Number of robots increases. Yeah, I think it is probably something that will be considered. But these robot arms, there's only a couple of million of them on the planet. Right. There's not that many. They've transformed manufacturing, absolutely, but there's not that many of them.
Right.
But when people talk about building 25 million humanoid robots a year, that's a whole different
It's a different ballgame. Right.
Yeah.
Right. Yeah. And the energy requirements of those, I think we'll get into a little bit just on their applications and how they realistically will be applied. Before we do that, I was reading up on some of your experience with robotics in different applications like mining or in environmental monitoring, which I also read that you pioneered a ton of stuff in. So I'd be also interested to hear maybe, I think manufacturing gets a lot of the pub, but mining is definitely one that I think also plays into where we go in the next 10, 20, 50, 100 years. How is the state of the art currently, and maybe any interesting changes that you've seen in the mining side or the agriculture side that are not really discussed because the manufacturing focus is so strong?
Yeah. So the robots, after the industry started in the 1960s, the initial focus was on manufacturing, and it continues through to this day. But after a while, people started to think that there's real limitations in what you can do if you're a hand with limited reach that's bolted to the ground. And then people started to think about, well, maybe robots should be able to move around. So, we're going to put them on wheels and you can use them to automatically move stuff around a factory. And then people started to think, well, why do we have to be limited to the factory? And this is probably this area, it's called field robotics. It's taking robots out of the factory and into the field. That really started to grow in the 1990s. And there's huge differences between operating in a factory and operating in a field. So in a factory, it's pretty organized, right? You know where everything is. The robot knows where it is and where everything is. With respect to the robot, we roboticists refer to that as a structured environment. And so when a robot in a factory goes and picks something up, so I've got a cup here, the robot wants to come and pick it up. It doesn't see the cup, right? It just knows that the system designer has told it the coordinate, the X, Y, Z coordinate of the cup in millimeters, and the robot is really good at going accurately to a particular set of X, Y, Z coordinates. So the robot's really quite stupid in that respect. If the cup wasn't there, it would still reach over, close its fingers, right, and move away. Once you're outside the factory environment, that you can't rely on absolute accuracy anymore, right? That robot superpower is of no use.
Right.
So you're an apple picking robot in an orchard. How do you know where the apples are? Yeah. Right? No one's going to tell you the XYZ coordinate of the apple. If you're in an underground mine, how do you know where you are? How do you know where the ore is that you need to pick up, or where should you be drilling a hole into the rock face to insert explosive? And that's where the initial robot paradigm, if everything's based on accuracy, we know where everything is, that fails in field robotics. And so around that time, then we had sort of innovations in sensors. So cameras started to become small enough that, the robot could hold it in its hand. And then we had laser scanners and things like this. They started to emerge in the 90s. So now what the robot's doing is pointing its sensors at the world, trying to figure out what's there and where it is. And then it adjusts its behavior, its motion, to suit. It's got a goal. It knows where everything is. It makes a decision about what it should do over the next 100 milliseconds, and it does it, and then it looks at the world again and repeats that process. And that's the guts of any robot system. You
right.
Look, you plan, you move a bit, and then you repeat. And so for the mining industry, that's where I first got involved in field robotics. And you go to a mine site, there's all these big machines controlled by a human. So in an underground mine, in a surface mine, huge machines by a human. So sitting in a nice, comfortable cabin using joysticks to move, a bucket, ultimately that picks some stuff up, they drive it somewhere else, and then they put it down.
Right.
Not that different to what a robot does in a factory, but the environment is so complex, we rely on the skill of the human in the cab to drive the joysticks. So field robotics is about adding a whole bunch of sensors to the machine, add a computer to figure out what to do next, and then you kind of hotwire the joysticks so that the computer controls the machine, right, not the driver. And that's how we got started. That's how most sort of people in the mining robotics business got started. We modified human-driven machines to make them essentially robots.
Yeah. Yeah, it's very impressive. And it was the early days of this. Was it a very structured kind of, I don't know, as I'd be familiar with a lab environment at university, or is it more like you're in a garage and you're kind of hacking things together?
So you could think of a couple of use cases. So one that we did was in underground mines. So you're driving a vehicle as like a front-end loader. It's got a bucket on one end. It's hinged in the middle so that it can steer, and it drives through a network of underground tunnels, picks up some ore, and then runs backward and dumps the ore into a hopper. So it was a self-driving vehicle, actually, but it drove in a network of underground tunnels. And so it needed sensors that tells it where it is with respect to the walls of the tunnel and where it is with respect to the intersections in that tunnel network. So by 96, 97, we had vehicles, quite big vehicles that could carry 10 to 20 tons of ore, driving 20 kilometers an hour through underground tunnel networks.
Yeah.
And this is a long time before the modern generation of self-driving cars happened.
Right.
But the underground environment is easier because there's no random pedestrians, there's no random cyclists, there's no traffic lights.
Right.
It's an easier environment in which to drive.
Right. And that, I think, is a kind of a good transition because, as you mentioned, the self-driving feature, we're seeing that with the Waymos, the Teslas, and all of the other manufacturers that are trying to deploy the self-driving capabilities. There's also the crossover into, I think, the humanoid robot settings, because while there is the manufacturing application, it seems like there is also a pretty big demand signal for other applications that would maybe fit in that field application setting for residential or maybe some others. What's the current landscape like for the humanoid robot setting and maybe the self-driving features? Where is that now, and what are some of those challenges that are kind of preventing widespread deployment?
So in addition to the mining robotics, which I've talked about, there's a few other sort of classic field robotic applications, and the ones that are often mentioned is forestry. So it's machines that go and cut down trees in forests, agriculture, and building and construction. Mm-hmm. They're all quite complex environments in their own way. What humanoid robots give us is the ability to move over very uneven terrain, where perhaps wheeled locomotion is not going to cut it. But I think that the big driving force for humanoid robots, I think I saw my first humanoid robot maybe mid 1990s in Japan, and the Japanese researchers really led the game early on. And I have to say, I was utterly freaked out when I saw my first humanoid robot. I just thought it was deeply wrong.
Yeah, sci-fi movie plots.
Yeah, exactly. But they don't faze me now, and there's almost ubiquitous, or certainly in the places where I go. But the motivation for the humanoid robot originally was targeted at aged care or helping people in the home. Because the Japanese professors, even back in the 90s, they realized that Japan had a rapidly aging population. Mm-hmm. So these professors in their middle age were thinking about their future, and they wanted to be looked after when they were old, and they thought the answer's got to be robots. Well, we can debate that, but anyway, that was the thinking, and that's why they started. In your house, there's lots of things that need doing, right? There is, vacuuming the floors, washing the dishes, cooking the dinner, stocking the fridge, moving stuff from your car to the fridge, making the bed, all of these things. And they're all things that we humans can do very, very easily.
Right.
The question was, do we build a robot that does each one of these things? Do we make a robot kitchen that cooks meals, and we make a robot dishwasher that loads itself, and we have a robot floor cleaner and a robot laundry system that does washing and ironing? You end up living in a house with 50 different robots,
right,
each one doing a special task. And those tasks are really hard. So today, the only thing that's robotic in many people's houses is the vacuum cleaner. It was the easiest thing to do, and the next easiest thing is really hard, and we still haven't been able to crack it. But the thought is that if you've got something that looks exactly like a human, same rough size, same sort of manual dexterity, it can use all the tools that you've already got in your house. So it can go into your kitchen, it can open the drawer, it can take out the tools, it can open the fridge, it can get out the food, it can use a saucepan and a fry pan in your stove or your microwave. It can go and do the laundry, it can grab the vacuum cleaner and go and clean your house. It could actually get into the driver's seat of your car and drive you somewhere.
Right.
It's the one machine that can potentially do everything for you.
It's just about the controls and
yeah. But initially they were so clunky and so big and so much lacking in performance that it really wasn't. we saw that it had potential, but it wasn't feasible.
Right.
But what we're seeing now with humanoid robots in the last year or two, I think has changed a lot of people's perception. And we sort of, that original rationale for using humanoid robots, I think now we would say tick. Yeah, it's probably possible in not too many years.
Right.
Where 10 years ago we would have said it was 50 years or a century away.
Right. And actually, you already mentioned this before the call as well, but you're at a robotics conference as we speak. And, I'm curious what the demonstrations that you're seeing look like at the conference and, maybe how distant those might be on a timeline, because I think it's moving a lot faster than maybe the median forecast maybe expects, is my personal expectation, but maybe you have a different thought.
So at this conference, which is primarily an academic conference, so you see a lot of blue sky stuff coming out of labs that won't be a product for a number of years. There's a lot of startups coming out of university robotics labs these days. So I think a lot of graduate students sign up to a grad program with an expectation that they're going to come out with a dissertation and a startup.
Right.
So that's a big change in mindset in recent times. What we see on the exhibition floor is stuff that's mature enough to already be products. So we see drones, and we see lots of robot arms doing somewhat sophisticated manipulation tasks. So the robots that were in factories all those years ago, the robots are still in factories today, and not very general purpose when it comes to picking up objects. So they generally have custom designed tools that we bolt on the end of the robot to pick up the thing that the robot's job is to pick up.
Right.
If you just put a jumble of everyday objects in front of a robot, and a classic industrial robot, you will fail to be able to grasp some of these things, because like you try and pick up a book, and you've only got 2 fingers, it's not easy.
Right.
Or if you've got a suction gripper and you try and pick up a sieve, it's not, you can't pick up a sieve with a suction grip. So people are trying to work out with a more complex hand. So we see a lot of robot hands now, anthropomorphic hands. So they've got five fingers, or they have a thumb and 4 fingers. So they really do mimic the structure of the human hand.
Mm-hmm.
And the human hand, I don't think we could argue, is the best possible thing to pick things up with, but it works for almost all the things that are in our everyday life, because we designed them to be
in our everyday life
pick upable by human hands.
Right.
So if you build a robot with a human hand, it's going to be able to pick up all the things that are useful to humans. That's the thinking. So a lot of robot hands, a lot of demonstrations of robots picking things up, and a lot of humanoid robots of all different sizes, all different price points. And actually this afternoon, and I'm missing it because it's on right now, is the robot procession. So they get every vendor in the exhibit to basically have their robots move in convoy.
The march.
And this great big long line, a march of robots through the exhibition.
Man.
And everybody is there, crammed 5 deep on each side of the runway, watching the robots.
Well, that sounds pretty exciting.
And these are serious robot geeks. These are people who do robots every day, but they still will go and see this, because to see so many robots in one place is still actually quite surprising.
Incredibly exciting too. Yeah. Well, hopefully we can make this podcast worth it, because that's a tough one to miss.
Yeah.
Yeah. And so dexterity, and you're seeing a lot of humanoid form factors, the applications, as you mentioned, it's just going to fit into more areas of our everyday life if it needs to. In the manufacturing side, for the humanoid robots, I think Figure has some test applications with, I believe it's BMW. And then you're seeing some others that are coming out also frequently in the automotive industry. Is that kind of the largest adopter right now? Is that?
It seems to be in manufacturing. So BMW, as you mentioned, is this kind of noteworthy example. And the other is in logistics. And so, in the modern world of e-commerce, there's a lot of stuff that needs to be gotten off shelves in distribution centers, fulfillment centers, and put into boxes.
Right.
And at the moment, that's done by an army of people. And Amazon have really led the charge here in the way they configure their fulfillment centers. They have these shelves that are picked up by by robots. And then they bring the shelves to human pickers who reach into the shelf, grab the items out of the shelf, put it in the box. Next shelf comes past, they get the next item out. So they have invested massively in robot technology. They probably own the biggest robotic fleet on the planet. I don't know now how many robots they have, but they're a robot-enabled business. Without robots, they couldn't do what it is that they do. Robots are doing the stuff that is easy for robots to do, right? So to pick up a shelf and move it from, warehouse floor to where a human picker is standing is actually a pretty easy job for a robot. The reason we still have the human there is the human is really good at looking at a shelf and whatever. Amazon have got a lot of product, right? And so whatever the product is, the human can just reach into the compartment and grab however many of them they need and put them in the box.
Right.
And that's the bit that robots are still rubbish at, right? It's the visual recognition and the hand-eye coordination to be able to grasp that object quickly, reliably, and put it in a box. So the humans are there because robots can't do that job yet.
Yeah.
And that, for companies like Amazon, that's the final frontier, right? They want to automate that as well. And then I guess once it's in a box, the box is taken by a big truck to another distribution center, and then a smaller truck, and eventually to someone's house. And that also involves humans driving vehicles.
Right.
And they're looking at that bit as well. So a humanoid robot will get out of the truck, come and knock on your door and give you the parcel.
Yeah.
Or it comes by drone. Yeah.
Yeah. Yeah. So, it's kind of an interesting, again, to the sci-fi kind of plot that I think a lot of people go to. How long do you expect that gap for accurate, reliable identification of whatever a robot is trying to, say, pick out of an Amazon distribution center? How long until we get to that stage, especially as we consider how AI fits into some of these different applications for kind of visual recognition or kind of processing information?
So the recent advances in AI have made enormous strides, right, in terms of the speed and the accuracy with which we can recognize objects. So I suspect that it's good enough for use in the next few years. I think that the weak point is still going to be the robot manipulation, grasping of the object.
Right.
That's still pretty clunky. But to know where the object is, what kind of object it is, that's a good part of the battle. The rest is actually controlling the motors in the hand to be able to pick it up. And you see lots of demos, online videos on YouTube from Figure, from Tesla, showing robots doing things that look pretty cool. I think my beef with these is that at the moment, I think they're highly curated. They're cherry-picked.
Right.
And we're not seeing how generalizable these tasks are, how much coding or prompt engineering was required to make it happen, how often does it fail, how fast is it really compared to humans. In the robotics community, we have a bad habit of speeding up videos to make them less boring.
The hype cycle.
Yep. Good people put an X5 or X10 down the bottom so it's sped up. Other people are less straightforward, and that muddies the waters. The other thing that we see a lot of is the robot is actually controlled by a human being off to one side. And there was an infamous Optimus demo. Right. I think it did the rounds last year. I've got a lot of comments on LinkedIn. I piled in, but you could actually see the guy with the joysticks in the corner of the picture. So the robot looks almost as good as a human. Oh, it is a human. Yeah. There's just a wire. That's
right.
Yeah. So my other fear is that there's a lot of investment going into humanoid robots at the moment based on what I think is probably these highly curated videos, and I think quite over the top estimates of total addressable market. And there was, again, there's a lot of this stuff on LinkedIn I follow. There was a post earlier this year. Somebody issued a report and said that the TAM for humanoid robots was 25 million per year. And that's that's an interesting number because I come from a country with about 25 million people.
Yeah.
So Australia, I think maybe we're 27 million now, but that struck me. That's as many humans as there are in Australia every year.
Right.
Is what we're going to be building, and what does the supply chain for that look like, and what's the energy consumption for that look like, and that's how we got connected, right?
Right. Exactly. Yeah. And I think the need on paper, makes perfect sense. You have in many countries, I think US is this way as well, where you have relatively low unemployment. There is a struggle to fill some of these skilled labor positions or maybe manufacturing positions. So it makes sense that, 25 million number, my initial question is, okay, well, how long does each robot actually last in its real world application? What does that look like nowadays for those battery packs that they're running on? I think Tesla, rough order of magnitude, it's going to be on a single digit kilowatt hour battery pack. Is that the case? And how long are these actually running at kind of normal human activity levels?
So I think we still struggle to get decent specifications for these robots. Yeah. It may be that they're there and I haven't found them, but I haven't seen specs for the Figure robot or for Optimus. What I did find was it said that it would work for a day on a charge, and I think maybe it even said the kilowatt hour rating of the battery pack. But I did the maths based on us. If we're working hard, we're exerting 400 watts. And I figured that the Optimus battery pack would probably would last less than 8 hours.
Yeah. Similar to the math that I had as well. Yeah.
Yeah. So if the robot battery pack only lasts for 8 hours, then what happens? Does another robot come out and replace it and the other one goes off to recharge, do battery swaps? But it means that if you need N robots in your facility to do the work, you're probably going to need some multiple of N if you want them to all be working continuously.
Right.
Because you're going to have to be swapping robots out while other ones are charging. Another issue with the humanoid robots is they all come with 2 arms because they're humanoid, and not all tasks require 2 arms. So, the manufacturing industry uses single arms to great effect. So many things that we use every day are built by one-armed robots or many one-armed robots in succession. Many packages are put on pallets or depalletized using one-armed robots. So it may be that the humanoid has got more capability than is needed all the time, which is kind of a wasted capital investment. And they also, if they're just standing at a workbench doing a task with 1 arm or 2 arms, they're burning energy just to stand up.
Right.
Where human beings are very efficient. If we stand still, actually, we don't use very much energy. Humanoid robots still consume rather a lot of energy even when they're not moving.
Right.
So that's kind of a waste as well.
Yeah. And then factoring in, the extra energy consumption for the intelligent systems with AI, I think it gets to a pretty interesting type of calculation, especially, thinking about some of the grid struggles that even the US has and is kind of a question all over the world, AI being the big focus, but I think it's also just the industrial electrification. That's another incremental load addition that I think is difficult to quantify. So
absolutely. So we've got EV charging,
right.
Growing, and then we've got data centers.
Yeah.
And data centers are now a huge growth industry. And as what we're seeing with a lot of the tools like Gemini and the latest from ChatGPTs, the inference is now much more expensive. It used to be the training cost you a lot and the inference was cheap.
Yeah.
But now with this kind of reasoning thing that they're doing,
exactly.
The inference is getting to be quite expensive, and that's gonna cause a huge stress, I think, to energy systems.
Absolutely. Yeah, we've done some of this, and it's an interesting calculation because the first iteration of the ChatGPT, like the GPT-2s, the rough estimate was that is 10 times more computationally intensive or energy intensive than a Google search. And then as you add in each element of its inference capabilities, and as you mentioned, the reasoning, you take that from 10x to 100x to even more. So you definitely see how, if you recognize the demand signal, that's going to be growing pretty quickly, which is, part of what we're, discussing here at Mobius is just how ready or adaptable the traditional utilities are to meeting that new demand that have traditionally been pretty slow moving. So it's a very interesting time. A lot of volatility in the underlying resources, and so creates some interesting questions for folks. Do you have any interesting or unexpected examples of applications for robotics, humanoid or other, that you maybe didn't expect to see in the last few years?
I think there's nothing that has been particularly unexpected to me. I think the drone revolution has sort of gone on quite quietly in the background. We don't have drone delivery of items yet, but there are so many other amazing drone applications, particularly in mapping and inspection in hard to reach places. Drones are starting to move now from being able just passively taking pictures or scanning things to actually to having an arm and actually being able to do things essentially from a skyhook, which is amazing. So, I've seen videos from a university lab of a robot changing a light bulb, up really high. You can just fly up and unscrew the old bulb, put another one in. So that's something that is a bit unexpected to me, is to see robots actually flying robots physically manipulating.
Flying robots with arms. That's, it's just getting even better.
So, maybe they could do window washing and things like that. Instead of having to hoist people down on ropes from the roof, the robot flying robot up with a squeegee and do its thing.
Yeah. Get rid of some of the high risk positions, maybe for the sensitive human. One of the personal questions that I'm very curious to hear some of your thoughts on is how robotics in their current form and maybe going forward are going to be able to accomplish more in fields like regenerative agriculture, permaculture. I know you have a lot of background in the agriculture space with robotics. So those are areas within ags that have historically relied on a lot of manual inputs. Do you see this kind of as a paradigm shift in how food production happens around the world? Is it going to enable smaller operations to scale? Or I'm just curious if you have any additional thoughts.
Yeah, I think robotics has a big potential in agriculture, and that's been recognized as a bunch of startup companies working in agriculture. And even, long-term players like John Deere, right? They have self-driving tractors that can automatically pull implements over fields. One of the things that interested me a lot, and I was involved in a project that was initiated by a very innovative farmer in Australia, was looking at reducing herbicide use. So herbicides are generally not very nice chemicals, and we deploy way more of it than we actually need into the environment, which is damaging to the environment. But the side effect that nobody saw 50 years ago was that plants would become resistant to herbicide.
Right.
And this is not a very mainstream story, but in agriculture, it's huge. Herbicide-resistant weeds, and you look at the numbers, it's costing agriculture industry billions or trillions, depending on which country you're in. And that's happened because of indiscriminate use of herbicides, like indiscriminate use of antibiotics, leading to antibiotic-resistant bacteria. So what can you do about that? Well, you could have a robot that could go over a field and moving slowly, and it could look at every individual plant and make a decision about good plant, bad plant. And if it's a bad plant, then it can destroy it, but not by using herbicide, right? It could just physically, stab it, or flamethrower or steam. All of these things have been proposed, or microwaves have even been proposed. And once upon a time, before industrial scale agriculture, a farmer would go through the field and they would look at each plant, good plant, bad plant, and they would remove the weed, right? When agriculture scaled up, the only way it was possible was through large scale, indiscriminate use of herbicide. So spraying machines are hugely wide and they pump out tons of stuff. A lot of it goes into the air, goes into the river. So the robot allows us to go back, rewind, 400, 500 years or something in agriculture. If the robot's cheap and it's solar powered, and you've got lots of them in the field, then you can get back to, you can regain the scale, right? But it's discriminate.
Mm-hmm.
And that to me would be a fantastic thing because you get rid of the weeds, which is important. Farmers are saving a lot of money because those chemicals are not cheap. Farmers spend a huge amount of money on these chemicals.
Yeah.
The robot doesn't need to be big and heavy. It may even be able to be powered perpetually by the sun. As the sun comes up, the robot starts working, kills some weeds until the sun goes down, and it repeats the next day.
Right.
And it's kind of a nice ideal, but it's not infeasible.
Yeah.
And folk are working on these sorts of things.
Yeah. Yeah. No, it's very exciting and something I keep my eye on as well. So it's very, very exciting time to be watching kind of the state of technology. So I really appreciate you hopping on with us today.
My pleasure.
Awesome. Well, thank you, Peter. And we'll put some information in the show notes and link out to all the stuff that you're doing.
Terrific. Thank you.
Thanks for joining us at the Energy Desk. Again, this is a limited series. So if you want to hear more episodes, you'll have to let us know by hitting follow wherever you get your podcasts or by sending me a message at amelvin@mobiusriskgroup.com. See you soon. And please keep in mind, this commentary contains our views and opinions and is based on information from sources we believe are reliable. This commentary is for informational purposes, should not be considered investment advice, and is not intended as an offer or solicitation with respect to the purchase and sale of commodity interests, or to serve as the basis for one to decide to execute derivatives or other transactions. This commentary is not considered promotional material.